All right, one more straightforward derivative with the quotient rule. And I have a function here that at first glance doesn't even seem like it has a quotient. We have the tangent function. We haven't learned the derivative of the tangent function yet because we were waiting for the quotient rule. Remember that tangent is equal to sine over cosine. Right, so here is where the quotient rule comes in. We just need to take the derivative of sine over cosine using our top over bottom quotient rule up in the upper right-hand corner. So we're going to start off with our denominator, which is cosine, times the derivative of the top. Derivative of sine is cosine. So that's our bottom top prime minus top. Bottom prime, derivative of cosine, is negative sine. Okay, so I'm going to multiply this by a negative sine x all over the bottom squared. So cosine x squared. And there's a lot of simplification that goes on here, right? I've got cosine times cosine. I can write that as a cosine squared. And then I've got a negative sine times a negative sine. That's just going to be plus a sine squared. And then on the bottom, I can just write this as cosine squared x. All right, and I'm not done yet. Resist the urge to cross out those cosine squareds. They don't cancel because of the addition up top. What does happen is this cosine squared plus sine squared. So hopefully you learned in your trigonometric past that that's an identity. Sine squared plus cosine squared is always equal to 1. So that simplifies this tremendously. We just have a 1 over cosine squared. All right, and that's a perfectly good answer for this derivative. We actually do this a little bit differently when we're writing down the derivative of tangent, just to make it a little bit more succinct. Okay, so I'm going to rewrite this as 1 over cosine x squared. If I distribute that square the way I've written it, 1 squared over cosine squared, that's the same thing. And I did that because 1 over cosine is the secant function. So this is really the secant function squared. So secant squared of x. That's usually the way that we write down the derivative of the tangent function, although 1 over cosine squared is perfectly useful. We usually write it as secant squared of x. All right, so let's use that new rule that the derivative of tangent is secant squared to find the equation of the tangent line to f of x equals tan x at x equals pi over 4. All right, so regular old tangent line problem. We'll write down our point slope form of the equation of a line. This time our x1 is pi over 4. We're going to find f of pi over 4 for our y coordinate. And as always with the tangent line, our slope is going to be f prime at our x value. All right, so let's start off by finding f of pi over 4. F of x is just tangent, so we're looking for the tangent of pi over 4. And tangent is sine over cosine, so this is the sine of pi over 4 divided by the cosine pi over 4. And if you look on your unit circle, pi over 4 is the 45-degree angle line in the first quadrant there. And both sine and cosine at that point are square root of 2 over 2. So you get root 2 over 2 divided by root 2 over 2, which just gives you 1. It's a nice y coordinate. And then we need to find f prime of pi over 4. So f prime of x is going to be the derivative of tangent. The last slide we just derived that was equal to secant squared, so we don't want to rework that. So we need to find f prime of pi over 4. So this is secant squared pi over 4. All right, so remember that that notation, secant squared of pi over 4, actually means to find the secant of pi over 4 and then square it. Let's see, so secant is 1 over cosine. So you're going to have 1 over cosine of pi over 4, which is square root of 2 over 2. And I definitely don't want to leave it like that. Let's see what happens. So I do a little keep change flip here. I've got 1. We're going to flip the second fraction because we're dividing fractions, 2 over root 2, and then square it. And I can kind of ignore the 1, right? That's not really changing the number. I'm just going to square the 2 and square the root 2 to simplify. So 2 squared is 4. Root 2 squared is 2. So this derivative actually looks pretty nice. It's just a 2. All right, so let's go plug those into our line. So I've got y minus f of pi over 4 was 1. Our derivative is 2. And x minus pi over 4. All right, so just a little bit of simplification to make this easier, and then we'll go take a look in Desmos. All right, so y minus 1 equals 2x, 2 times, let's see, we'll do this in my scratch work, 2 times pi over 4. The 2 and the 4 are just going to reduce to pi over 2. So I've got 2x minus pi over 2. Now I'm going to add 1 to both sides. It's going to be kind of hard to combine that with the pi over 2. So we'll just say 2x minus pi over 2 plus 1. And that should be our tangent line. Let's go take a look at a tangent line to the tangent graph. All right, so here we are in Desmos looking at the tangent graph, and we were supposed to find the equation of the tangent line at x equals pi over 4. So I'm going to plot that point. We had pi over 4, and then we had found the y coordinate to be 1. And that looks perfect. That point looks like it's just there on the graph, so that's the point we hope our tangent line passes through. So we're going to have y equals 2x minus pi over 2 plus 1. All right, and that ended up in the same color. Let's see. Okay, there we are. Yeah, so our tangent line looks perfect there at pi over 4 comma 1. So the quotient rule can lead us to the derivatives of the rest of the trig functions as well. We did tangent derivative being secant squared of x. If you do the cotangent derivative, you'll get negative cosecant squared of x. Secant and cosecant both get 2 trig functions in their answer. Something that might be helpful, all of the trig functions that start with co in their name, cosine, cotangent, cosecant, all of their derivatives are negative. The other 3, sine, tangent, and secant, have positive derivatives.